Hello, welcome to M132 Introduction to Linear Algebra at AOU. In this section or this tutorial we will start with chapter 2. Chapter 2 is called Vectors, Linear Combinations and Linear Independence. And in this tutorial we will cover section 2.1. We start off with some definitions. Vectors in Rn. What are vectors in Rn? An n vector is a vector with n components. As you can be seen here, a vector which is a column matrix has n elements in it, v1, v2, v3, etc. to vn, is called a vector in Rn, where v1, v2 and vn belongs to R, are called components of the vector. Example, if the vector x is a 2 by 2 vector, 2 by 1 vector, it has elements 2, 5. This is a 2 vector, a vector in R2 or vector in the plane. Another example, y is a 3 by 1 matrix. It's a column vector. It's a 3 vector in R3 or vector in space or 3D, 3 dimension. Now, what are the operations that can be done with vectors? Two vectors can be equal. Two vectors x and y with components x1, x2, x3, xn, etc. and y1, y2, yn, etc. in Rn are said to be equal if the corresponding elements are equal. In other words, if xi is equal to yi, where I is between 1 and n. So the elements are equal. If all the elements are equal, it means that the two vectors are equal. Addition. How do we do additions with vectors? The sum of two vectors x and y in Rn, as seen here, is obtained by adding the corresponding elements of the two vectors x and y to obtain x plus y, x1 plus y1, x2 plus y2, etc. to xn plus yn. The next property is multiplication by scalars. In other words, to multiply a vector by a scalar value. The product of a vector x in Rn by a real number or real scalar value r is defined by rx, r times x, which is equal to multiplying each element of x by r. In other words, we get rx1, rx2, etc. to rxn. Example, if x is and y are two vectors in R3, as shown here, then 2x plus 3y is obtained by multiplying the vector x by 2 and the vector y by 3 and adding the two vectors. So we have 4, 6, 2 to be added to 6 minus 3, 12, and we add the corresponding elements of the two vectors to obtain 10, 3, 14. More properties. If we have three vectors u, v, w and in Rn, and c and d are two scalars that belong to R, two real numbers or scalar values that belong to R, then u plus v is equal to v plus u. The commutative addition property holds. Then the next one, u plus v plus w is equal to u plus v plus w. This is the associative property in addition of vectors. Addition of vectors, associative property. The third one is u plus 0 is equal to 0 plus u is equal to u, the 0 vector in Rn. U plus minus u is equal to minus u plus u is equal to 0. C times c, where c is a scalar value, c times u plus v is equal to cu plus cv. This is the distributive property. Then c plus d times u, where c and d are two scalar values, is equal to cd plus du, and c times du is equal to cd the product of the two scalar values times the vector u. Finally, 1 times u, scalar value of 1 times u, is equal to u. This ends the tutorial for section 2.1. Good luck.